he thought it was my next one on Skype. He like ran up and started talking to me.
All right. I think I just have 2 groups discussing right now. Hopefully that's what they're doing. What's going on?
Yeah, I did. Y'all are talking about that right now. Like, it's a really simple answer. You can't intimidate. That's not very random to do. You're just looking at one thing, though. And they're like laughing. Like, no.
You did randomly pick up everybody.
Starting chapter 8 now, right? Starting chapter 8 now. Yeah, that was already done. No, but we were working on 7 before this week. Yesterday, or not yesterday, Monday, we were working on 7 2. We skipped that. Yeah. 7-3 was already due, but 7-2 is due yet. Coming out of this. I know. Oh, did you do the wrong?
No, I didn't do the 7.2 because I thought it wasn't due.
Oh, okay.
So now I overdue. I have to work on it.
Yeah. I have to like highlight all the words and check off what I already did.
That's good. I didn't understand what
It goes out of order.
Outside of the
All right, that's a very interesting part of that. All right, guys, so I think everybody has talked to other groups, right? You got that sheet done, hopefully? So real quick, I just want to summarize what we found. When you're doing, and when I went into this, I hadn't actually taken this data before. I'd done something like this a while back, but I went back the last few semesters, that was brand new data. I had no idea how it was going to shake out. If you're curious, the actual number on Part D, that is the true average for that population of men or women. So for the men, it was 81.22, and for the women, it was 79.47. Right, so for the population, the actual average men's grade was a little bit higher. Now, let me ask you this. This is kind of interesting. Look at your Part D. Everybody's Part D. How many groups said no to that? I like it. I love it. This is cool. This is nothing. Don't look at them and go, ooh. I think there were 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, there's 12. A 90% confidence interval. What does that mean when you construct it? What does it mean? What would be the phrase you would say? Some of you guys wrote it. We are 90% confident that this interval contains the true mean, right? Because we're talking about that one. Which means if I make several confidence intervals, what percentage of them should not contain the true mean?
10%.
10%. And what's 10% of 12? 1.2. 1. Right? And how many? This is awesome. I had no idea. And there you go. 1 out of 12 did not contain the true mean. You guys with me? I mean, we just saw it happen, which is cool, golden. There's no way I could control that. You picked your own freaking numbers. I was just like, please. And I could have made you guys do it individually, but I wanted you to have the experience of group work on this, right? If I made you do it individually, I would have had, 40 some odd, and then I would have had a much higher chance of it happening. But it did. It's awesome, and it happened exactly the way the math says it should, which is not necessarily going to happen. Sweet. I like it. You guys semi with me here? So that's why that makes sense, and that's why they didn't do a damn thing wrong. That's statistics going, well, shit, sometimes it ain't going to work. All right. Let me see what else I want to say. Your part F for the true percentage of males or females. How many of you guys had your p-hat was higher than 75%? How many of you guys? All right, a few of you guys. If your p-hat was higher than 75%, officially you weren't allowed to make a confidence interval, but I told some of you guys just to do it anyway. Because then your NQ would have been less than 5. It would have been 16 out of 20 would have been 4, right? So officially it wouldn't have been normal enough, but screw it, just do it. Right? All right.
Can I do that in test?
Say again? You got to be careful. Yeah. On the test, you better not do it if it happens. But I'm not going to do that to you. If you don't realize it, you're the guy that's doing extra work, and that's kind of evil. I'm not quite that evil yet. A few more years, I'll be there. And then, so this is kind of like the first step. If you found a population, I think I was talking about like dolphins before and all kind of crap. If you find a population somewhere that you don't know what they're all about, this would be the first step. This would be exploratory statistics. Just find the mean, make a confidence interval, and compare it to what's known, and see if it's like evidence. So we say that normally about 3% of people develop cancer or something, right? So I go to this little island, and then I make a confidence interval. I go to this little island, and I see that 0.5% get cancer. So I make the confidence interval, and I get like 0% to 2.5%. Is that evidence that it's not the same as everybody else? Why is it evidence that it's not the same as everybody else? Because this is not in here. You guys kind of with me? It's sort of like the same idea as unusual versus not unusual, right? Versus usual. So this is what I would expect the true percentage is for that little group of people that have discovered versus everybody else in the world. So what am I going to do next then? If I'm this person that found this group of people, what am I going to do next? What do you think? This is evidence that what's true about these people on this little island. Somehow they don't develop cancer as much. Now what am I going to look at next? Yes, their habits, their diet, how much sun do they get exposed to, what kind of stuff do they do, what do they make their clothes out of, what kind of animals are there that they eat. You kind of with me? Do you understand? I want to see, and then we're trying to tease out, is there something I can make everybody else in the world do that will lower cancer rates everywhere? And you got to be careful with that kind of thing, like the Mediterranean diet or the paleo diet or shit like that. You got to be careful about applying something because you don't know which variable actually made the differences. So in the Mediterranean, very often the cities are set up so you don't drive everywhere, right? So you do a lot more walking. So maybe it's not their diet, maybe it's the fact that they actually move their asses more often. You kind of with me? So this is the idea of controlling for different variables so that you really know what's having the effect. And whenever you see a study that comes out and goes, oh, I know we said eggs were evil and now we say they're fine, it's because they didn't tease out all the variables in their previous study. And they're like, oh shit, it was actually this that made the people do this, and oh shit. So there's people just not being careful with their study. All right. Maybe. Good. Sweet. I like it. Okay, good. So any lingering questions from this little exercise? Anything left over from that? Is everybody cool with the fact that the T-score chart is a double duty dude now? If you look at the T-score chart and you stop, you get a T-score, which makes sense. It's called the T-score chart. But if you look at the T-score chart and go all the way to the bottom, you get a Z-score. It kicks ass. It kicks so much ass. Let it kick ass. Yay, kick ass. All right. So before I leave confidence intervals and get into chapter 8. Oh, scheiße. I wanted to show you this, and I've already upset one person with this. But it's not me, I'm just the messenger. Let me turn this dude back on so this side of the room can see something. And, I could have pulled up any study I wanted to, and I think we've seen this kind of thing before. But any study you look at nowadays, they're going to give you at least the confidence interval, right? We've looked also where studies gave us the p-value. You kind of with me? So this study is all about, and this is actually a study I just saw this morning in the paper, and it's about a link between developing cancer and using muscle building supplements. So again, this is an initial release of early findings that has not been duplicated yet. So you have to be careful about how you react to this. Always talk to your doctor. But anyway, this is, I really want to explain very quickly what this sort of means a little bit here. There you go, okay. See that OR, the odds ratio? So I got that to work and I came way over here. The odds ratio is, if it was 1, that would mean that your odds remain the same. If it was less than 1, that would mean your odds actually go down. So is it possible from what they found that the odds are actually 1 or less? So what this is, it talks about so this odds ratio is the effect of the muscle supplement stuff on the probability to get cancer. So if it's above 1, that means that it actually has an effect. So the confidence interval they created, and notice what confidence level they used. That's the most common one to use. Does it include 1? Does this interval include 1? Can you guys see it? I blued it out. Maybe that was a bad idea. Does it include 1? No. Thank you. No, it doesn't, right? It starts at 1.11. So this is evidence that it's more than 1. In fact, they probably could have made a larger confidence, like a 98%, and it probably still would be above 1. And that would be kind of more significant evidence. Are you guys with me? If you make a 20% confidence interval and you're like, I found it. No, you didn't find shit. But the larger confidence interval, the 95, 98, 99, and you show evidence, that's significant, more significant evidence. Because the chances you're wrong are smaller and smaller and smaller. How we doing? All right, good. So one thing you can do when you do a study, you can do a 95%. You're like, well, that's pretty good. Let's try the 98 and see if it still works. And then that's a stronger evidence to support. So they probably did, I'm assuming. And they're like, oh shit, it's below 1. Let's just stick with 95. You guys kind of with me here a little bit? All right. And again, there's always a probability that they're wrong. That's at the heart of any of this stuff. There's a probability that they're wrong. Until somebody else does it. Like it could have been you guys did something. I'm not picking on you guys, but you're the ones that just happened to do the study in here, and it showed what was the wrong thing. What sucks in real life is we don't know what the real story is, right? Normally, I don't know what the real mean is. I have no idea. I'm conducting a study. So you do your study, you have no idea, you don't have a clue you're wrong. Until somebody else does the same thing and finds something to corroborate with you, I'm not going to believe it. So this I'm not going to believe yet. Until some other people recreate this. And of course, that's all part of the scientific method. Somebody else has to do it before I really believe it, right? So like cold fusion. All right. Enough of that. Whew. So, we're going to get a little bit into chapter 8. Just the barest little bit. And then I'm going to let us out a little early. Next time I'm going to have a... Not yet. Don't get packing up yet. What's the matter?
No, we want to study, guys.
Yeah, learn from that. It's a good attitude to have. Next time I'm going to have an updated homework sheet. So you know what's going to happen in the near future. Some of chapter 9 I'm probably going to end up making extra credit. But the nice thing with chapter 9 is it's exactly like chapter 8, just larger equations. So once we get through chapter 8, you'll understand what you need for chapter 9. Okay. So here's the idea with chapter 8. One thing that's wrong with confidence intervals... Oh, yeah, you can give me that later. Or right now it's probably good. Go ahead and pass the sheets over. Get that out of the way. Yeah, I told you to put all your...
Oh, we don't have to.
As long as one of them has all your names on it, that's great. Put all the group members' names on there.
Oh, you don't have it with you? Oh, I can give you paper, like actual paper. Sure. Enough to use that one thing. Oh my god. Funny. That's old age. Okay.
You're just like my daughter.
You
You were my daughter. I started early.
Oh, you wrote your name.
No. Like I just wrote like.
My niece says biology is smart. Oh,
Anatomy and physiology?
yeah.
Yeah. I took physiology in high school though, so
Oh, yeah.
I don't think I'm having a problem with it. And memorization
Yeah,
is
I know,
like
that's
super easy.
It's
So
easy. And like I think I could like 8.
I mean, it depends on like everyone's study habits. Some people are good at memorizing some quiz, but some people you don't need to like it.
No, I'm good. I used to be good when I was young. And then things to memorize everything.
That's the only thing that's hard.
Yeah, that's all there is. That's really
Yeah, that's it. Yeah.
The medical field. That's all it is. You have to be good at
So, I want to try to make this kind of clear. I don't know if you guys realize. What's the confidence interval idea is where I try to, I take what I can get a hold of, which is X bar or P hat, and then I build an interval around that, and I catch so much data to say I'm so sure that I caught the real parameter, the real mean, the real percentage of the population. That's the whole idea behind the confidence interval. Can somebody tell me, is there there's a kind of a flaw in that chapter 8 tries to come at it a different way. So one thing I can use confidence intervals for is to prove that two things are different, or to show that there's not enough evidence to say that they're different. So most of you guys should have seen that your intervals overlapped for the means. So between men and women, there was not evidence that they were different. The reality was they are different, right? Barely. And that's why a lot of your intervals overlapped. All right, cool. So that's one way to test a claim. So if I made a claim that those means were different, all the work you just did was say, I can't back your claim. I didn't find evidence to support what you're saying. You guys kind of with me? Does that make sense? I mean, it's basically what we just said earlier. All right. Chapter 8 realizes one little flaw in confidence intervals. When I make a confidence interval, I build it around something I'm not sure about, which we have to. When we make a confidence interval, that's the only thing we know. So we have to build it around that. But is that the real middle? No, that's the whole point. I don't know what the real middle is. I'm assuming that this is close enough to it. So really, the reason that some don't capture the real mean is because they started too far away from the real middle, right? So somewhere there's a real middle, and most of you guys, when you did your confidence intervals, they caught it. But you can make one that X bar was way down here, so when you make your confidence level, it didn't catch it. All right. That is actually kind of a flaw in this. It uses a number for the middle that really isn't the middle. Okay. But it's all captured in the uncertainty. I'm still okay to do it that way, because I'm saying people, I'm this sure. I'm not 100% sure. I'm only 90% sure. Stuff like that. So here's what chapter 8 does. Chapter 8 and the idea of hypothesis testing. Okay. What it tries to do is it tries to go back, and this is why the book has been doing this whole semester. It keeps asking about, is it statistically significant? P is 0.0001. What does that mean? It keeps hammering us with that idea because it's getting us ready for chapter 8. So in chapter 8, what I do is, for example, let's create an example that's got a little bit of concreteness to it. That would probably be preferred. So let's say that it's known that the average gas price, what would the average gas price, I need to fill my gas tank up today. So what is it currently? What would you say it is right now? Like $3? Is it $3?
I don't know.
That's awesome. As long as you're not going to like Carmel Valley or somewhere. I saw like $5 up there all the time. So let's say it's $3.
$3.
Yep. All right, so let's say that there's a study that was done. We know that the average gas price for all of San Diego is $3. You with me? And you say, no, where I live, it's much higher than that. You with me? So there's a claim that's being made. There's an accepted middle. In fact, this is not just accepted. It's known that that's the middle. And then there's a claim about either that the fact that it's changed, or in this case, that some sample of some smaller group of the population has a different mean. How are we doing so far? All right, so this is the known mean for all of San Diego, and then you're like, well, I live in this. Somehow I got a place in this really, fancy place, and my gas is like $3.40 or something crazy. All right, so there's a claim that the mean is more than $3. So today we're not going to, we'll see. Today's going to be a lot of just explanation of why things work. Next week I'm going to give you guys a very detailed thing. It's going to be a 5-step process. When I was taught, it was an 8-step process. So you're welcome. But where do you think, if I want to show evidence of this, if I take a sample, where do I want that sample to show up to show evidence that my claim is true? Where do I want it not to show up? If I go take a sample near my house, where would it suck for it to show up considering my claim? If my claim is that the mean gas price near my house is more than $3, it would so desperately suck for it to be less. But and I really want this to be clear right now, whatever number I get from my sample, is it necessarily the truth of how much gas costs around me? No, because it's a sample, right? Good. Which means that in order to be evidence that this is not true for me, it's got to be really far away. It's the whole idea of, it's got to be in an area where, like, P comes out to be less than 0.01 or something, or what we use is 0.05 or 0.01. That's the same number you keep seeing throughout the whole book. The probability, and that would be, because if this really is the middle, stay with me, if that really is the mean in my area, there's a chance that I could take a sample and it would show up here, right? There's a chance I could take a sample and it could show up there. That's true, right? Because that's what this whole picture means. But if I did take a sample and it showed up here, the probability that just happened randomly, and this should sound vaguely familiar, the probability that I just happened to pick a sample that was that much more expensive is less likely than the probability that my gas price is actually higher, right? So if I find a sample that's way the hell up here, where the probability of that happening is less than 0.05, for example, then what that really means is the picture for near my house probably looks more like this. The mean really is higher. I really want this fundamental idea of I'm going to get a sample, but in order to be evidence, if I got a sample and it was $3.01, is that higher than 3? Do you think that's enough evidence to say, no, good. It is more. Why is it not enough evidence? Because it's really likely to get somebody that's $3.01. Ooh, good job. Does that make sense? So it's got to be far away. So the whole idea of chapter 8 is how far away from the mean is your sample, and is that far enough away? So 2 of my steps, there'll be a 5-step process in this whole thing. Maybe I'll even get into a little bit. Yeah, sure. There'll be a 5-step process. And step 3 will be what is far enough away. So that's like setting up the boundary, saying what's far enough away. Right? So it's sort of like if we wanted to get somebody on the Chargers who was really fast. I'm trying to draft somebody who's fast, right? What am I going to do to kind of check somebody out before I let them on my team? I'm going to have them run like some kind of 600-yard dash or something. 600 yards is pretty far. 50-yard dash. Or 600 just to see what's happening to them at the end. 50-yard dash. And what am I going to do? I'm going to have a benchmark. And I'm going to say if you're below that benchmark, that's not evidence that you should be on my team. If you're above that benchmark, that's evidence that you could be on my team. Right? Does that make sense? That's really all this is. So I think let's do this. Let's actually attempt a problem. We're going to do this. And the next time we'll get a lot more specific about the ins and outs of every step. But today I just want to give you a little feel of what the steps are. So let's stick with that gas price problem. It is known that the mean gas costs is $3 for San Diego, with sigma, I'll be nice, equal to, what you got, Jeff? Let's say 37 cents. This is known. Somebody's already got all the data for all the gas stations. So that's why I know the population standard. So there are situations where it makes sense that we know the population standard deviation, because we have all the data. We feel, or let's say, I feel it's higher near me. How large of a sample should I take to be able to do any of the work I need to do? Has to be larger than 30. Get gas. All right. So gas stations are probably not the best way to go with this, but oh well. Let's pretend like gas stations are like 7-Elevens. There's one. Well, it's almost true. So we take a sample of 31. We get just barely enough because we're tired. We just sat through stats class. We desperately need to go decompress. We take a sample of 31 gas stations near where we live. All right? And we find X bar equal to $3 and, what you got, Jeff? 17 cents, sure. I probably went a little overboard. Sorry. Let's make it 309. I want this to be a little more interesting. All right, so what we're trying to show then is that enough evidence that our claim is correct? Is that enough evidence? So right now I can't say. I don't know. 309 is more than 3, but it's only a sample of 31. It's a relatively small sample. I don't know if that's enough evidence. Right? Just like when you created the confidence intervals, the mean you got was definitely more than the mean for your compatriot female group that came and talked to you, but that was not enough evidence because once you made the confidence intervals, they overlapped. You didn't have enough evidence. So I don't know if that's far enough away to be evidence. So our first step really is just kind of collecting what our claim is in mathish. Right? So what is the claim in pure math symbols? Yeah, because we're talking about means, right? So our claim is that the mu is bigger than 3. So what's never going to show up in our claim that's up here that's related to $3? This would never show up in our claim. Because we have a claim before we go take the freaking sample, right? So that's never going to show up. There's a reason we went and got a sample. We must have had a feeling of something. We're like the scientists. We think, oh, if I put this into the beaker, this will happen. Let me go try it. So we have a claim before we do it. We didn't just go, I pour stuff. I don't know. We had a feeling of maybe it'll blow up. I have a feeling something's going to happen. I think something's going to happen. Let's see. Right now I'm trying to think how deep don't want to get into this. So what would the opposite stance be of that? If that's my stance, if that's what I believe, what's the opposite of that, mathematically? Be careful.
Less than or equal to.
Good. right? And in the book, you'll see they actually use this, which in one sense makes sense, in another sense makes no sense at all. So we'll talk more about that when we get there. Obviously, the opposite of greater than 3 is less than or equal to 3, right? So if I cannot show that this is true, if I can't say this is true, that must mean I can't say this is wrong. Does that make sense? They're opposites from each other. All right. Good. I'm trying to stay away from too technical stuff yet. The second step really is always to check to make sure we can do anything. So what do you think I have to check here? And actually we kind of made it work. To be able to use z-scores to talk about probabilities, what's got to be true? And why do we know it's normal here?
Greater than 30.
Yeah. So since n is greater than 30. And now that I know that it's normal, I want to know what can I use. Do I use z-scores or do I use t-scores? Yeah, why do I know I can use z? Because I know the population standard deviation. Because this is data that the city would actually, somebody might have, right? Gas Buddy might have it. You know that app? And we know sigma. So this means it's normal enough, check. We know sigma, which means those two together mean I can use z-scores. So the first step is, what the hell are you talking about? The second step is, what are you allowed to use to talk about it? I like it. And then the third and fourth step are the heart of the test, the hypothesis test. The third step is, how far do I have to get? I know 309 is higher than 3. Well, how high do I have to get? How fast do I have to run, coach, so I can get in your damn team? Right? So I can get an endorsement and get lots of money. And then spend it all by the time I'm 32. So, there's one thing I got to tell you for the third step, so that I can actually figure out what the benchmark is going to be. I got to tell you what probability is acceptable. And let me ask you this. This kind of came out already. How many tail tests do you think this is? How many tails do you think this test has? Remember, we said this earlier. On this picture, where do I want my sample to show up? To show evidence. I only care about this side, right? So it is a one-tail test, which is why your t-score chart has 1 and 2 tail options. How we know so far? All right. So let me go back to a symbol from before. Recall this. Do you remember that symbol? It's in the book. The little fish dude. I've said this before, but I really want to make it clear. The little alpha, the little fish dude, represents the area in your tail or tails. So if alpha was 0.05, that's how much area is in my tail or tails. You guys with me? So if I had a 95% confidence interval, there would be 0.05 in the tails. That would be 0.05. Alpha would be 0.05 split between 2 tails. And that's why for confidence intervals, they actually have this symbol in the formula. Personally, I hate that because it makes it look more complicated than it really is. Just look at z-score. So I don't like that. But this symbol comes back in. This is important. So they have to tell me. So let me ask you this. If you're trying to show evidence to an insurance company, like they just built a new fire station closer to your house, and you want to show evidence to the fire station that they'll get to your house quicker, to the fire insurance, they'll get to your house quicker so your premiums should go down. You with me so far? That sounds like something you might want to do. Who's going to set the level of evidence? Who's going to say what's enough evidence? Who, in that case? Do you get to say what's enough evidence? No. Who gets to say it? The insurance company does. And they're going to probably set the bar high. They're probably going to say alpha of 0.001 or something crazy. So do you see? So right now, if I make alpha 0.05, I really want this to make sense. You ready? If I make alpha 0.05, where's the tail in this test? Up. So in that tail goes 0.05. Got it. If I made alpha, so where's my sample got to show up? So here's really what's going on. This is the benchmark. This is what my sample has to get past. to show evidence. So not only does it have to be different from this, it's got to be different enough from that. And that benchmark is what they have to get past, right? So that's nice you run faster than the average of the people I've already got. You got to run even faster than that. I want somebody, I want the next rocket. Ishmael, is that too far in the past? Yeah. If it was two-tailed test. This is a
1.
And how do I know that? I only want to show that it's greater. Two-tailed test would be if I want to show that it's different. If I want to show something is different, it could be bigger or smaller. So if I was doing a problem, a hypothesis test problem, they said, we feel that the mean has changed, two-tailed test. Because how do you change? You get bigger or you get smaller, right? Do you even look for it? All right. So let's say that it is 0.05. If I made it 0.01, what would happen to my benchmark? Which way would it go? I'd have less stuff, so it would be harder. I would make it, if I made alpha 0.01, it would be harder to pass the test. You guys kind of with me? If I make alpha 0.01, my tail gets smaller, which means my benchmark must be further out. All right, some of you guys are semi with me, or at least you're making me feel that way, which I appreciate. So, not surprisingly, let's see if you guys are cool with this. What we call this level that the insurance company tells me, or the EPA tells me if I'm trying to prove that some lake is too contaminated, or the government tells me if I'm trying to prove that they're wasting money, or whatever I'm trying to prove something, whoever sets that level, this level is called the level of significance. Very worried that I spelled that wrong. Did I? I can't remember. All right, so let me recap. We have what the hell are you talking about? So that's what the claim is, and also what the opposite is. What are you allowed to use to talk about it? So we figured out we're allowed to use z-scores to talk about it. Cool. What is far enough away? We still haven't finished finding that. You guys are like, really? Holy shit. Now, obviously, actually doing a problem is not going to take this long because you're not going to have me explaining every step as you do it. All right, so don't freak out yet. Now, help me out. This is old news. Can somebody please tell me what that z-score would be? Now that we know we're allowed to use z-scores, what would that z-score be?
1.645.
Some of you guys might just know it. Now, I appreciate that, but why is it not negative? Because it's on that side. If I would have felt that it was less than, it would have been negative on that side, right? I like it. But if you look at your t-score chart, go to one-tail test on your t-score chart. One tail, 0.05 on one tail, look all the way at the bottom, and you see 1.645. See if I'm right. You never know. I might have, something might have happened in my brain. I could be gone right now. All my dreams. Freaking you out. All right. So this Z is 1.645. That means any sample I get, in order for it to be enough evidence that the mean in my neighborhood is actually more than that, it's got to have a Z-score more than 1.645. So let me write a little statement. If my Z-score is more than 1.645, we have shown evidence for the claim. And to be honest, there's some more technical language I'm not going to introduce yet that we're going to use every time for this, but that's the idea. That's at least the idea. Do you guys still see how everything relates to the same idea? If it's far enough away, well, what's far enough away? Well, that's far enough away. Okay, finish what you're saying. Okay, if it's that far or more, it's evidence that the mean really is higher. What's the probability that I'm wrong if I say that? If I find something out here, what's the chances that I'm wrong? Roughly 5%. I say roughly because there's other things happening with this problem. That's good enough. It's about 5% chance that I'm wrong. Okay, good. 2 more steps and then we're going to head out a little early. Yes?
Evidence for claim.
Oh yeah, sorry. If Z is greater than this, we have shown evidence for the claim. To show that the claim seems to be right. I like it. If we get something less than this, but like barely less than it, I'm going to go take another sample. I'm like, shit, I failed now. Let me go try again. We'll see what that means semantically when we talk about this later. Let's do the last 2 steps. Let's be careful with the words I use, because people will start packing up if I say next time. That's the magic word. So the 4th step, well, I've said what's far enough away. So now what do you think I want to do? I want to look at my sample and see what the... do it. I've said what z-score has to happen to be far enough away. So now I want to look at my sample and make a z-score and see where the hell it is. So let's collect my sample data. What do I know from my sample? X bar is 3.09. What's sigma? 0.37. Before I make a z-score, what do you think I have to do? Always. For his hypothesis test. Because what did we do? Did we take a sample?
Yes.
Hell yes. Oh, are we talking about sample means?
Yes.
Hell yes. So what's got to change? Standard deviation. Kick ass. It's just a step. It's in there. Because that's always, you're always going to get a sample to do something. So you're always going to change. So what's the new standard deviation? 0.37 divided by?
And number?
31.
Square root of 31. Kick ass. Somebody help me out on that.
10.
Can't be bigger than what it was.
0.066.
Okay, cool. So 0.066. Okay, cool. I'm with that. Let me make this point right now. Screw it. It's fine. When I say standard deviation out 3 decimal places, it's non-zero decimal places. Can you imagine if you got a standard deviation of 0.000004, then you go, oh, it's 0. No. You keep going until you get something that's not 0, and then you take 3 of those. So what's the next? Is it 0? That'd be fun. All right. Fun? Okay. Cool. So 3 places, non-zero. Right? If you ever took chemistry, it's sort of like sig figs in there. Right?
Yeah.
Oh, shit. We won't call it that anymore. All right. Okay. So what can I do now? You see, I got all my information here, basically. I'm going to take this away. Can you calculate the z-score now? Yeah, what's the z-score? So it's always my data minus the mean, and we're going to accept that this is the mean. So here's another thing about hypothesis tests. Have you ever heard somebody say, okay, assuming you're right, look at that. What? You know, assuming that I can't jump that high, and then I jump that high. Look what I did. So we're going to say, assuming you're right, assuming it is 3. So we assume that really is the mean. We're going to try to show a contradiction. We're going to say, if that really was the mean, how did our sample get so far away? Does that kind of make sense? Assuming you're right, how did I just do what I did? It's so unlikely what I just did that you must be wrong. That's what we're hoping is going to happen. Does that make sense? Believe it or not, that's really what's going on here. It's not just me dumbing it down. That is what's going on. Right? So it's my data minus the mean. We're assuming that mean is true. Like I just said, so that's 3 over the standard deviation. Yeah, 0.665. And what do we get? 1.35. Okay, cool. I like it. This is awesome. So $3.09 sounded like it was a decent amount above 3. You with me? Is it far enough above 3? How do you know that?
Less than.
Yeah, I didn't make it far enough. Did I make it far enough? No, I made it this far. Right, I made it up to 1.35. So very often I call this, just so you get ready for it, I call this Z star. The reason I call it Z star is twofold. I've already got a Z score that we looked up here, right? So that's already Z. And when I find it on my picture, I put a little star on it, so that's the one I found. Is that cool? So on everything I give you on the handouts, it's going to have a Z star here on step 4. It's going to say find Z star. So Now you know what I mean. Right? I'm not talking with a German accent or something. Find the star. No. Where is the telescope? I don't know. That's wrong. I do. So before I go, and actually I tell you what, we'll talk about 5, but I want to do one important thing. On the studies I've shown you before, and I could try to find one right now, but I've already shown you, they had the p-values up there, didn't they? P was 0.001, P was less than 0.05. That's the one that we looked at last time. Do you remember that? No. I like it. You're honest. I look. Honesty is always appreciated. So we just pick another one of these studies.
0.001.
Plugging here can help treat baldness. No, it's fine. That sounds really backwards. Emotional sensitivity. Painkillers to become psychokiller. Let's see if I can access the actual study. Let's see if we can do that. Probably won't restore this. I'll try one more. If it doesn't work, I'll just remind you. Remember, just make sure iPad's making one better, okay? Do it. There we go. Okay. All right. So look at this here. See that? Is that statistically significant? The probability of whatever they happen to be talking about right there in the study. Let me zoom in. You guys are like, you can see it, Jeff. That's nice for you. Right here. That is the probability that whatever it is they're studying would have happened by chance. So it's way too high. There's a 30% chance it would have just happened. Whatever you're looking at wouldn't have had an effect. So P has to be small in order to show something, right? In fact, up here, P has to be less than 0.05 to show something. And that's why on a lot of these, like the one we saw last time, it said P less than 0.05. They're saying, hey, we found statistically significant evidence. That is saying, oh yeah, this shit, it wasn't statistically significant. But they have to tell you, hey, we looked at this, but it wasn't good, right? So somewhere else they probably have P less than, hopefully they have something that was significant, or else why did they do this? All right, sure. That's good enough.
I can't remember.
So many words. All right, it's not. So, watch this. Here's what a p-value is, and this is the last thing. Can you tell me, alpha is the amount of area in the tail that this z-score makes, right? Does that make sense? So that's how we got the z-score, isn't it? We looked that alpha up to get the z-score. So alpha is the amount of area in this z-score. The p-value is the amount of area above my z-score, in the tail of my z-score. That's all it is. So it's a nice analogy there. Alpha is the amount of area in the tail of the critical z-score, that boundary z-score. The p-value is the amount of area in my z-score's tail. So what area would be above 1.35? Let me draw this again. So we got 1.35. What area is in here? That's the p-value. And we already know it's not going to be smaller than 0.05 because we already know we didn't make it far enough. So what do you get when you look it up? Make sure. Say again? 0.9115. All right, so that would be this. 115? So what's this? 0.0885. Beautiful. So it's a p-value of 0.0885. That's not significant, is it? That's not significant. Statistically significant findings. It's greater than 5%. So if my z-score I found would have been in here, it would have been smaller. The tail would have been smaller. P would have been less than 0.05. It would have been some smaller number. So all this stuff is starting to come together. Now trust me when I say this. When I see you again, and this time I actually am saying the words, the magic words. So next week, I'm going to have a nice, really spelled out, I use it every semester, I kind of like it, about each step. How to set it up, what the hell does it mean? How to set it up, what the hell does it mean? And we'll fill in all the little technical details I skipped today. So that's plenty. Yeah, thank you. Please give me back my calculators, if you have them. You will give me the answer.